Soon, I will repeat my two most important animations. There is still important information to understand about them. This information will really clarify the grand unification of physics. My goal is to make this science film understandable to everyone. However, for a few minutes, I need to cover some advanced topics for the superstring mathematicians, because in my opinion, this new physics will influence superstring theory. If you do not understand superstrings, don't worry. Please, just keep watching. This will be brief. In the two key animations that I will repeat, one animation uses fields, the other uses vectors. How I see, how I imagine, how I visualize these waves is beautiful, elegant. However, neither mathematical technique using fields or vectors seems very mathematically elegant at describing these spherical waves. It remains to be seen who will do it, but in my opinion, when some mathematical genius describes these waves in the best possible way, it will be with an exciting new form of mathematics. I must inform superstring mathematicians they have been misled by the physicists. Historically, the line of reasoning started going off course roughly 300 years ago, when Isaac Newton came very close to understanding time. Isaac Barrow, he was Isaac Newton's mentor, was partially to blame because apparently he told Newton that time was not a motion. This incorrect reasoning became entrenched in physics. This incorrect reasoning caused a variety of physics problems. That is, until Einstein developed special relativity. Now, while special relativity did indeed solve a problem in physics, it entrenched this incorrect reasoning even deeper. Special relativity needlessly forced mathematicians to try to solve this incorrect reasoning by adding extra dimensions to the three physical dimensions of space, leading to extraneous non-physical dimensions of space-time. The very essence of the problem is superstring mathematicians use way too many dimensions for space, simply because the physicists don't understand time. While mathematically it is of little concern to work with extra dimensions, the mathematics used in physics must describe nature. Because physicists have not understood time, mathematicians incorrectly concluded that space must have extra unseen dimensions. However, there's absolutely no physical evidence for these dimensions. There's no evidence for dimensions of space beyond the three you can see by simply looking around. Not only is there no physical evidence for any extra unseen dimensions of space, it is logically impossible that evidence will ever be found for them. Recall some well-known logic that applies here. Obviously, this well-known logic is being conveniently ignored, overlooked, or worse, forgotten. Sometimes astronomers and physicists claim they have evidence that space itself can be warped. Logically, any physical evidence that has or ever might be spotted can, instead, be attributed to the mass and energy in space, not to space itself. That same logic applies to space having extra unseen dimensions. While mathematically, making extra unseen dimensions for space is mathematically valid, physically, any evidence that might someday be spotted could instead justifiably be attributed to the three obvious physical dimensions of space. A mathematician might say, I found mathematical evidence for the 26 dimensions of space. Someone else could argue, no, that is only evidence for one of the three dimensions of regular space. This argument will go on, and in my opinion, it can never be solved. Always remember Physics is all about describing nature. On the other hand, some areas of mathematics are esoteric. In other words, there are areas of mathematics that don't apply to physical reality. The math that can appropriately describe physics is a subset of all math. The math used for physics must describe nature. It is backwards then to think, if mathematicians can describe spaces in higher dimensions, higher than 3, then nature must have these unseen dimensions. Again, that is backwards. The way to think of it is this. The mathematicians are prepared for physical discovery. Later, if and only if physicists really do observe dimensions of space higher than 3, which I don't think will ever happen, then the way to think of this is the mathematicians have already come up with a way to describe this reality. Just because mathematicians can mathematically describe any number of dimensions, this does not make higher dimensions of space a physical reality. I believe I have the right to say this. My breakthrough in understanding time is critical here. Let me remind and emphasize 1 second of time is physically equal to a distance of 299,792,458 meters. This is a physical transformation that should be applied to any math that describes space or space-time that uses more than 3 dimensions. It collapses 4D space-time down to 3D space. I trust mathematicians will find this equality simplifies much of the complexity of superstring theory. Instead of having 10, 26, or some other value for space-time dimensions, using this equality, these large values should collapse down to simple 3-dimensional space. I trust mathematicians will eventually first discover and then prove that this equality factors out their extraneous and mutually dependent mathematical dimensions. They'll find this factors out the mathematical dimensions, leaving only the physical dimensions. This will continue to vex astronomers until they realize space and time are different. Space is a measure of extent. Time is a measure of motion. To summarize, in mathematics, a mathematical space can have any number of dimensions. In physics, the space of our universe is 3-dimensional. In my opinion, the space is 3-dimensional because nature has 3 fundamental fields that act at right angles to each other. At present, when someone is using spatial dimensions to explain physics, dimensions that go higher than 3, it is an example of how not understanding time creates unnecessary complexity and causes problems. It is interesting to note, in this area of mathematics, we have progressed from strings to membranes and now to spheres. The progression has been strings, which are 1-dimensional, to membranes, which are 2-dimensional, to spheres, which are 3-dimensional. Again, in a few minutes, I'll repeat 2 key animations. In recent years, one goal of superstring mathematicians has been to derive, mathematically of course, what these 2 key animations already show. I need to discuss the concept of solitons a little bit more. Again, this is another tidbit for the advanced mathematicians that are watching this. If you don't understand these terms, please be patient and keep watching. Superstring mathematicians want to describe both photons and elementary particles as solitons. What is a soliton? A soliton can be described as the mathematical representation of a self-reinforcing wave that maintains its shape while traveling at a constant speed. These 2 videos that I'm building up to physically show how to accomplish this mathematical goal, and much more actually. For example, this new physics also explains what happens to the soliton if it speeds up or slows down, if it is accelerated. In my opinion, all photons and stable elementary particles are physical examples of the mathematical idea of solitons. Personally, my goal goes beyond the goal of mathematicians. At this time, mathematicians are only concerned with stable solitons moving at a constant rate. The way I look at it is, even partially stable elementary particles like neutrons are physical examples of solitons. This view that includes partially stable particles expands the idea of solitons somewhat. Ricci flow. What is Ricci flow? First and foremost, Ricci flow is a mathematical concept. Ricci flow deals with geometrical manifolds. In mathematics, a manifold is like space. Mathematicians have no trouble working in 1, 2, 3, 4, or more dimensions. There is no mathematical restriction for how many dimensions a manifold or a space might have. These manifolds are like mathematical versions of nature's physical 3D space. This Wikipedia graphic might help you visualize Ricci flow. It is a series of blob-like objects. These blob-like objects are two-dimensional geometrical manifolds. That means they have a surface. They are not solid, they are hollow. As the shape of the blob varies, it transforms, it changes shape. This change can be generalized. This change is the flow part of Ricci flow. It is a geometrical flow. The mathematical concept of Ricci flow generalizes how this transformation takes place in any number of dimensions. So, mathematicians can describe how blobs like this can transform or flow from shape to shape in 2 or more dimensions. Notice how, as the manifold pinches or necks, it starts to resemble a spherical particle. That roughly spherical particle is a mathematical soliton. Notice how the bottom blob resembles a physical particle. That excites mathematicians. In essence, the mathematicians are trying to describe a physical elementary particle using a mathematical soliton by having a geometrical manifold warp into the blobby shape of a particle. Keep in mind, because these blobs are mathematical, the number of dimensions does not matter. 1, 2, 3, or more dimensions can be used. This is a classic case of being esoteric. This applies to mathematical ideas. It does not apply to nature, at least not yet.